All right. Welcome back to my channel. If you are new, please do well to subscribe. And if you are a regular, you are welcome. Thank you for subscribing. Today, we are going to look at differentiation by chain rule. And we are going to take more examples. Today's chain rule will incorporate a product rule and quotient rule. So I'm going to take two examples where we'll be solving uh, a problem that has to do with chain rule and product rule. And then we're also going to solve a problem that includes chain rule and quotient rule. So with that being said, let's go into the video. All right, like I said before, today's examples on chain rule will incorporate uh, both product and quotient rule. So I'm going to start with the one that incorporates product rule. So this should be our example 3. All right, so if you have, if y is equal to x, bracket x plus 1, let's say x squared plus 1 squared all to the power 3. Okay, find dy dx. Find dy dx. Solution. So here we are going to apply both chain rule and product rule. Remember what we stated in product rule. We said that dy dx. So in this case, I'm going to call this v. So this will be dv dx equal to dv dx equal to what we have in the bracket, I can call it w, equal to dw dx times d. Sorry, sorry about that. This should be dv dw dw times dw dx. And then remember, I'm going to call this u and then call this v. Then call what we have in the bracket w. Okay. So we will now have dy dx as We apply product rule as u dv dx, okay, plus v du dx. All right, so now remember that our dv dx is this. So we're going to have that dy dx is equal to u bracket dv dw times dw dx, okay, then plus v du dx. All right. Now, having broken all this down, we can get all our parameters in place. We have that y is equal to u v, where our v is equal to w cube, and then our w is equal to x squared plus 1. I hope you are following this. All right. So now let's differentiate this. Assuming we have this is what we're going to have. So dy dx would be u. We keep our u. What's our u? Our u is x. So we'll keep our x and then differentiate v. Remember that dv dx is dv dw times dw dx. So what is dv dw? Dv dw will be dv dw will be 3w squared. I hope you follow that. Where dw dx, sorry, dw dx will be 2x. All right. So now we keep our x. Dv dx is dv dw times dw dx. So we're gonna plug it in here. 2 times 3 will give us 6. So we'll have 6x w square. What is our w? Our w is x square plus 1. So we're going to replace this w with x square plus 1. So we're going to have bracket x square plus 1. Okay? Please follow it carefully. Any part you don't understand, try and play the video again so you can understand it clearly. So now we are done with this part. We add, put our addition sign, then our v. Look at what our v is. V is this whole thing, okay, which is w cube. And what's your w? This. So we're gonna plug it in direct. So we're gonna have I missed to put square here. There's a square here, this square. Okay, so we're gonna have this, which is x squared x squared plus 1 all to the power 3. Then what is du dx is 1. Okay. So with that, we can open this bracket. We have 6x squared bracket x squared plus 1 all squared plus x squared plus 1 all to the power 3. So with this, we are done solving this problem. So I believe this is very clear. If it's not clear, you can write in the comment section where you got missed out or where you missed it. And then I'll be glad to explain to you. Okay? And if you have similar problem that you cannot solve, you can bring it on. We have a private meeting where I can show you how you can solve it. All right. I'm going to take the second example. So, example 4. If y is equal to, let's say, sine x squared minus 1 or sine 3x squared minus 1 all over x to the power 7. Okay, find dy dx. Solution. All right, so now here we're going to use quotient rule, and at the same time we would apply chain rule. Okay, so what we're going to do is we say y will be sine okay, let me do it this way. Our y will be u over v. Okay, and then our u is sine. Okay, you see how I'm opening it up? Sine w. Okay, where our w is 3x squared minus 1. And then our v is x to the power 7. All right, so now we're going to use quotient rule and chain rule at the same time. So from here, we have that dy dx, okay, is v du dx, okay, minus u dv dx, okay, all over what? B squared. All right, so now here we have that du dw will be equal to du dw will be equal to du dw times dw dx. Sorry, this is supposed to be du dx, okay? Yeah. So du dx will be equal to du dw du dw times dw dx. So at the end of the day, in actual sense, if this the w cancels this w, we have our d dx back, du dx back, okay? So now we're going to plug it in right here, just like we did before. We're going to plug this in here. So we'll have that dy dx will be equal to v, okay? V bracket du dw times dw dx. Then we'll cover this up, minus u dv dx all over v squared. All right, so now let's apply this. So now dy dx will be equal to v. What's our v? Our v is x to the power 7. So x to the power 7 bracket du dw. Du dw, if you differentiate sine w, you will have cos w, okay? So we'll have cos w. And what's our w? Our w is what? 3x squared. 3x squared minus 1. Okay, so I cover this again. Then, all right, sorry. Before I cover this, I need to do the last one. That is the u dw times dw dx. So I'm going to do this one times the w dx will give me 6x. Okay, 6x. All right, so I'm going to cover this now. Okay, so this, I will now put minus u. What's our u? Our u is sine w. And what's the w? This. So we now put sine bracket of 3x squared minus 1. All right. So I'm going to say all over v squared. What's our v? Our v is this. So x to the power 7 times 2. That is x to the power 14. Okay. All right. So we can, is there any other thing we can do? Maybe we're going to multiply this with this. So we'll now have 6 times this. I have 6 to the power 8. Okay. Then cos 3x squared minus 1. Okay. Then minus sine 3x squared minus 1 all over x to the power 14. All right, so this is our final answer. It might not be that simple, okay? When you have, but if you take your time, know what to do, you'll be able to solve the problem. Thank you for joining me today. I will see you in my next video. Bye-bye.